Good morning, I am Mr. Ish. Thank you for joining me. We've looked recently at partial fractions decomposition, the simple cases. Now we're upping it in terms of difficulty level. We're looking at two examples here in which we will have what will be seen in the denominator, an irreducible linear factor. What is an irreducible linear factor? Look at this, 1 minus x squared. Compare this to 1 plus x squared. This can be reduced. It's a reducible linear factor because this can become 1 minus x times 1 plus x because it can be reduced. This here is an irreducible linear factor. You can't do anything else with it. So when you're looking at questions, rational functions in which you end up seeing this, what happens? Very easily, just don't panic. It's not hard. It's just a specific technique. Think of these two cases. One has 1 minus x, the other one has 1 plus x. These are simple cases. You put an a and a b, right? Simple as that. Now if you have an irreducible linear factor, forget what we had everything before or after. Supposedly here you have an irreducible linear factor, and we'll imagine we ended up on letter B because we had used up a for the previous factor. We're on letter B. What do you do when you have an irreducible linear factor? You don't put a single item here, you put an expression on the top, and your expression would be something like that, a linear factor and a constant. If you had like here a 1 plus x, which is a reduced linear factor, you'd put a single letter. But when you have an irreducible linear factor, you have to put an expression. Normally it'll be a linear variable and a constant based on what power or order of exponent you have. So we're looking at cases where you see something like this, then you put something like this on top. So let's look at two of those examples. Again, by no means there should be any reason for any of you to panic. Look at this. Look at the denominator, higher order exponent, 3 here, 1, ideal for partial fraction decomposition. I like to abbreviate that as PFD, ideal PFD example. 2 plus x, over here in the denominator you'll have x into 1 plus x squared. You see, we've got an irreducible linear factor, but look, we have again two factors, 1 and 2. So we know in terms of a template we should have two items. Right, we'll have an x in one item and we'll have 1 plus x squared in the other item. Over this simple reduced linear factor, you put a. Over this irreducible linear factor, you put a bx plus c. And now you do your common denominator, x times 1 plus x squared. This goes in that 1 plus x squared times, right? 1 plus x squared. Bx plus c will go with regards to its denominator in this variable x times. And you know all of this will equal to what you have right here. 2 plus x, but you see we'll have a square component, so I might as well add a 0x squared placeholder. It'll only help. Anyhow, I'm erasing this. Now open this up. You'll have a plus ax squared plus bx squared plus cx. You see this with that, that with that is equal to 0x squared plus x plus 2. Now look at your commonalities. I have a quadratic factor, and a quadratic factor because they have powers in terms of their variables to 2. I have an a plus b is equal to 0 in terms of these coefficients. Then I have a linear factor. I have a c is equal to this x, cx is equal to x, c is equal to 1, not too hard. And then I have a constant, a is equal to 2. You see how everything is so easy here. I already know what c is, I already know what a is. If a is equal to 2, b must be equal to minus 2, right? Because 2 minus 2 will give you that 0. So we have these values, 2, minus 2, 1. All you have to do is plug them right there in places of a, b, and c. I have an a as equal to a 2, so it's a 2. I have a b is equal to a minus 2, so we can just put a minus 2 here. And you can keep this positive, there's nothing wrong with you doing that. And a c is a 1, and I put a 1 over here. My partial decomposed fractions of this rational function are 2 over x plus minus 2x plus 1 over 1 plus x squared, and this answer here should be good. And this question has been done. Our second and last question for this video will be something similar. Let's look here. We have x squared plus x divided by x squared plus x to the 4th. What do you want to do? You want to first simplify everything, the entire rational function. You can bring an x, you'll have an x plus 1. Always simplify before you do this PFD technique. Here you'll have an x squared, you'll have a 1 plus x squared. You can still simplify this. This x will cancel out with that square. You'll have an x plus 1 over x times 1 plus x squared. You see something very similar as you did before. Two factors, one is a reduced, one is irreducible linear factor. Therefore you have two partial fractions, but they'll always add. One will be x, one will be 1 plus x squared. One will be an a, the other one will be bx plus c. It's very similar to the previous question, except here you have to simplify before you did any of this. Common denominator, x times 1 plus x squared. this goes in that 1 plus x squared times, right? And then you have bx plus c, which will go into that x times. Right over here, we can open it up. We'll have a plus ax squared plus bx squared plus cx is equal to your new numerator, not your original numerator, your new numerator. Bring in a place value holder, 0x squared plus x plus 1. Look at your quadratic terms here, here, and here. Look at your linear terms here and here, and your constant terms, this and that. And you can make your 3 linear systems of equations utilizing only the coefficients. Based on the quadratic equations or the quadratic factors, we have a plus b is equal to 0. And then based on the linear one, we have cx is equal to x, which is c is equal to 1. And then we have a is equal to 1. If a is equal to 1 here, b must be equal to what? Minus 1. Right? B must be equal to minus 1. We have 1, minus 1, and 1. So we have to just do nothing more than substitute. We have 1 over x minus x plus 1. Right? Minus x plus 1. If I want to rewrite all of this partial fraction in a good way, so I don't have a conglomeration of signs over there like a positive and a minus sitting together. You see I have a cluster of signs over here. How can I do it? I can do it like this. I can do 1 over x and I can bring the minus out. This minus will then impact everything over here wanted, right? You have 1 plus x squared here, you'll have x minus 1. Because if you were to open this up, this minus will impact with this minus and make that positive 1 as you want. But this minus will keep the x minus as you see. So this right here is a good answer. Perhaps a better way of writing than that. But the decomposed versions are done for this rational function. So you keep in mind, irreducible linear factor, as you see over here, leads to an expression or above it, bx plus c, versus just having a b. B would be over something like x plus 1, but bx plus c would be over some non-reducible linear factor like x squared plus 4, x squared plus 1, or any of these factors which cannot be reduced further. That's a peculiarity you need to keep in mind. Thank you for watching. Have a nice day.